So the price of lithium and like all the raw materials and the battery cells went crazy. It doubled. The price of lithium, I think, went up at almost like fivefold or like 500%.
This isn't just another battery update. This is a moment the future split from the past. For decades, lithium has ruled silently, powering your phones, cars, and even your homes. But beneath that rule, problems festered. Skyrocketing costs, fire risks, and a stranglehold on global supply. Now, out of Tesla's most secretive lab, something has emerged that may shatter that empire forever. A new kind of battery forged not from scarcity but abundance, not from fragility but strength. And it doesn't just compete with lithium. It obliterates it. Is this the end of lithium's era or just the beginning of something bigger? Let's find out. How is Tesla's aluminum-ion battery ending lithium this time? Tesla's aluminum-ion battery isn't just a replacement for lithium. It's a total demolition of it. At the core of this shift is a simple truth. Aluminum ions carry 3 positive charges, while lithium ions carry just 1. That means aluminum moves 3 times more energy per ion, instantly boosting energy density without any exotic materials or complicated engineering tricks. But the real blow to lithium is safety. Lithium batteries are known for forming dendrites, tiny metal spikes that can pierce through battery separators and cause fires or explosions. Aluminum-ion batteries don't form dendrites at all. They are stable from -40 degrees to 85 degrees Celsius, far beyond the range lithium can handle safely. That means no risk of thermal runaway, no risk of battery fires, and no need for costly cooling systems. Then there's the supply issue. Lithium is scarce with reserves concentrated in just a few countries. Aluminum, in contrast, is the most abundant metal in Earth's crust, available nearly everywhere and easy to refine. It also avoids the use of cobalt, eliminating one of the EV industry's biggest ethical concerns in chemistry, safety, and supply. Aluminum doesn't just improve on lithium, it makes it obsolete. Why is aluminum ion 10 times better than lithium? Aluminum ion doesn't just outperform lithium, it breaks every limit lithium ever had. Start with energy density. Lithium batteries max out around 250 Wh per kilogram. Tesla's aluminum-ion cells achieve over 5,000 Wh kilogram. That's not a small upgrade. It's a complete transformation. A Tesla Model 2 could go from 330 miles of range to more than 3,000 on a single charge. Then comes lifespan. Lithium batteries wear out after about 2,000 charge cycles, just a few years of daily use. Aluminum ion can last over 50,000 cycles, enough for 70-plus years. That's possible because the electrodes heal themselves. Micro cracks that ruin lithium batteries are repaired automatically in aluminum cells, keeping them strong for decades. Charging speed. Lithium needs nearly an hour for 80%. Aluminum ion hits 100% in just 10 minutes without overheating. That's because aluminum ions move 3 times faster and don't struggle with heat buildup and safety. Aluminum batteries can't explode or catch fire. They are non-toxic and chemically stable. Lithium batteries have caused thousands of EV fires. Aluminum makes that danger disappear in every category: energy, speed, safety, and life. Aluminum ion doesn't compete with lithium. It completely replaces it. How unbelievable are the exclusive features only aluminum-ion batteries can unlock. Aluminum-ion technology doesn't just outperform lithium. It unlocks features that once seemed like science fiction. First comes a self-healing electrode system. Tiny cracks, the kind that destroy lithium batteries over time, are repaired within seconds in aluminum cells. Research shows these repairs restore 99.7% of the battery's original structure, sometimes even improving performance beyond 100% through more efficient ion pathways. In other words, the battery doesn't just recover, it gets stronger. Then there's the power storage revolution. A single aluminum-ion Tesla could hold up to 2,000 kilowatt-hours, enough to power multiple homes or entire work sites. It's more than a car battery. It's a mobile power station. Tesla's survival mode system distributes energy intelligently during blackouts or emergencies, keeping essentials running for weeks. And perhaps most shocking of all is deep sleep mode. Unlike lithium, which degrades in storage, aluminum-ion enters a crystal-like stasis. It loses almost zero capacity even after 10 years. And when reawakened, it's ready in 30 seconds with full performance. These aren't minor improvements. They are new categories of capability, and they prove that aluminum ion isn't just a better battery. It's a completely new era of energy technology. Now, first, like always, be sure to hit the like button down below. It helps us out tremendously with the reach of this video. Thank you. How does the aluminum-ion battery make EVs truly affordable for the masses? This is where aluminum-ion technology transforms not just batteries, but the economics of transportation itself. Lithium once made EVs expensive, fragile, and exclusive. But aluminum changes the equation completely. It's the third most abundant element on Earth. And that abundance means stability. A 50 kilowatt-hour battery pack that used to cost up to $7,500 with lithium can now be built for as low as $2,000 to $4,000 using aluminum ion. That single shift cuts the total price of an EV by up to 20%. Recyclability adds another layer. While lithium batteries degrade with each recycling process, aluminum-ion batteries retain up to 95% of their efficiency even after multiple cycles. This reduces long-term production costs and waste. Tesla knows what this means. The upcoming Model 2, rumored to start under $15,759, is an answer to mass market domination. It won't just be cheaper, it will outperform everything in its class with over 400 miles of range and a full recharge in under 15 minutes. Most important of all, it will last a lifetime. One aluminum ion pack could run for 70 years. No replacements, no fire risk, no compromises. This isn't just affordability, it's liberation from everything holding EVs back. Why 2025 is the beginning of a new battery era. Back in 2022, Elon Musk said things would go ballistic next year. That year is now. And what we're seeing isn't just an upgrade, it's a turning point. After nearly 7 years of silent development in Tesla's Nevada lab, the aluminum-ion battery is finally ready for commercial scale. This isn't speculation. It's real. Quietly, Tesla has begun production, and insiders suggest we're just months away from a full reveal, likely at Tesla's rumored 2025 battery day this September. What makes this timing so powerful is everything happening around it. Lithium supply chains are cracking under pressure. Prices are volatile. Governments are scrambling to regulate extraction. And consumers, they are growing tired of EVs that cost more than they save, that take too long to charge, and that come with hidden risks. Aluminum ion erases all of that. It arrives just when the world needs it most. If Tesla unveils a fully deployable aluminum-ion battery this September, 2026 will be the first year electric vehicles truly go mainstream. Not because of subsidies or hype, but because they finally make sense. This isn't the future arriving slowly. This is a new era slamming the door shut on the past. Why the end of lithium means more than just a better battery. This isn't just a story about aluminum replacing lithium. It's a shift in how we think about energy, technology, and independence. Lithium's dominance brought progress, but it also came with a price. Environmental harm, geopolitical tension, and limited accessibility. Aluminum ion rewrites those rules entirely. Suddenly, energy isn't scarce or dangerous. It's stable, safe, and everywhere. Think beyond cars. A battery that lasts 70 years, charges in 10 minutes, and powers your home for weeks changes everything. Remote villages can run without grid access. Disaster zones can recover faster. Entire industries can rethink how they store and distribute power. And for consumers, the most expensive part of an EV, the battery, becomes the most durable, affordable, and sustainable component. Tesla isn't just creating a better product. It's quietly dismantling the infrastructure built around lithium, cobalt, and fossil fuels. Billions invested in lithium mining, refining, and transport may soon be worthless. And the companies that can't adapt, they'll be left behind. The aluminum-ion battery is more than a breakthrough. It's a reset button, a new baseline. And when history looks back, 2025 won't just be the year of another battery. It will be the year energy itself was reinvented. What comes next? And who gets left behind? The race has already started, but most of the world hasn't realized it yet. While other automakers are still refining lithium packs and chasing marginal gains, Tesla is preparing to leap forward with a battery that changes the entire game. Aluminum ion isn't a distant experiment anymore. It's entering production backed by existing global supply chains and decades of aluminum infrastructure. That means it can scale fast, much faster than lithium ever could. The companies still investing heavily in lithium tech are facing a dangerous future. They are building on ground that's about to collapse. With lithium prices swinging wildly and supply chains tightening, there's no guarantee that batteries will be affordable, let alone competitive. And once Tesla's aluminum-ion batteries hit the road, cheaper, safer, longer lasting, the rest of the industry won't have years to respond. They'll have months. Consumers will move quickly. Who wouldn't want a battery that never needs replacement, never catches fire, and recharges in the time it takes to order coffee? This isn't just a new feature. It's a new expectation. The question now isn't if aluminum-ion will take over. It's who's ready to embrace it and who's still betting on a past that's already over. This isn't the slow rise of a new battery. It's the sudden collapse of an old empire. Lithium had its time, but the cracks have become too deep, the risks too high, and the price too steep. With Tesla's aluminum-ion breakthrough, we're not just entering a new chapter. We're closing the book on everything that came before. Safer, faster, cheaper, and stronger. This battery changes what's possible for cars, homes, and the entire world. The shift has already begun. So ask yourself, are you watching from the sidelines or stepping into the future? The end of lithium isn't coming. It's already here.